Here is a number that can be built out of cubes in two completely separate ways. One cube plus another cube gives it. A different pair of cubes, sharing nothing with the first, gives the exact same number. The number is 1729. Take 1 cubed, which is just 1. Add 12 cubed, which is 1728. 1 and 1728 land on 1729. Now throw those two numbers away and start over. Take 9 cubed, which is 729. Add 10 cubed, which is 1729, and 1000 also land on 1729. 2 cubes on the left, 2 different cubes on the right, and the same total on both. There is no overlap in the parts, and yet the sums agree perfectly. That coincidence is rarer than it looks, and the whole point of what follows is to show that this number is the very first place it can possibly happen. Before chasing the coincidence, fix what a cube is, because the word is going to do a lot of work. A cube of a whole number is that number multiplied by itself 3 times. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. The gaps between them grow fast. 1, 8, 27, 64, 125. And by the time you reach 12 cubed, you are already at 1728. Now play a simple game. Pick any two of these cubes and add them together. 1 plus 8 is 9. 8 plus 27 is 35. 27 plus 64 is 91. Every choice of 2 cubes gives you some total, and most totals you will ever see got there in exactly one way. There is a single pair of cubes behind them and no other. And here is the thing that makes a repeat feel unlikely. Because the cubes are spread so far apart, the totals you can build from 2 of them are scattered thinly across the number line. Most whole numbers you point at are not the sum of 2 cubes at all. Of the ones that are, almost all sit alone, reachable by a single pair and no other. So finding even one number with 2 pairs behind it means 2 of these rare, widely spaced sums have collided on the exact same value. So the question sharpens. Add 2 cubes, get a total. When can a total be reached by 2 genuinely different pairs? Not the same pair written twice, but 2 separate choices of cubes that happen to agree. To find the first repeat, we do the honest thing and check every total in order. Line up the whole numbers from small to large. For each one, ask a single question. Can it be written as 1 cube plus another cube? And if so, in how many ways? Most numbers cannot be written that way at all. A handful can in exactly one way. We are waiting for the first number that can be written in 2 ways, and we simply climb until we hit it. 9 can be done one way, 28 one way, 65 one way, 91 one way. The marker climbs past hundreds of numbers. 60 different totals below our target turn out to be a sum of 2 cubes, and every one of them in a single way. Then the marker reaches 1729, and for the first time the count is not 1, it is 2. That is the entire claim, made concrete. 1729 is not just a number that happens to be 2 sums of cubes. It is the smallest number for which that is true. Nothing below it repeats. Look at the 2 builds directly, because seeing them next to each other is the whole payoff. On the left, 1 cubed plus 12 cubed. 1 is tiny, 12 is large, and the large one carries almost the entire weight. 1728 out of the total, with a single unit added on top. On the right, 9 cubed plus 10 cubed. 9 and 10 sit right next to each other, and they split the load almost evenly, 729 against 1000. One split is lopsided, one is balanced, and they have no cube in common. Not 1, not 9, not 10, not 12 appears on both sides. These are 2 independent recipes for the same amount, and the amount they agree on is 1729. That is the object in full. 2 disjoint pairs of cubes, 1 shared total, and no smaller number where it happens. This number has a name, and the name comes from a short exchange that took place in 1919. The mathematician G.H. Hardy went to visit Srinivasa Ramanujan, who was ill in a hospital outside London. Hardy mentioned, mostly to make conversation, that the taxi he arrived in carried the number 1729, and that it seemed a rather dull number. Ramanujan answered right away that it is not dull at all. It is the smallest number expressible as a sum of two cubes in two different ways. That reply is why this whole family carries the name Taxicab. The number 1729 is written as tar of 2, the taxicab number for two ways. And the definition Ramanujan gave on the spot is exactly the one we built by climbing the number line. Smallest total reachable as two cubes in two different ways. Ramanujan did not have a computer sweeping the integers. He simply knew these numbers, the way other people know faces. The sweep we watched is the slow, honest version of something he saw at a glance. A fair worry at this point is that 1729 might be a lucky accident, a single quirk with nothing behind it. It is not. Keep the marker climbing past 1729 and it soon halts again. The next number that is a sum of two cubes in two ways is 4104. 2 cubed plus 16 cubed gives it, and 9 cubed plus 15 cubed gives it 2. Same story, larger stage. After that they keep coming. 13,832, then more, thinning out but never stopping. So 1729 is not the only number with two cube builds. It is the doorway. It is the first member of an endless list, and being first is exactly what makes it worth a name. And the gaps between these repeat numbers stay wide. Between 1729 and 4104, there is no other number with two cube builds, and the empty stretches only get longer as you climb. Each one is still a genuine collision of two rare sums. They just never quite run out. That is what a good mathematical object looks like. Not a single trick, but the smallest case of something that goes on forever. Once you know to look for two ways, the natural next move is to ask for three ways, or four, and that turns one special number into a whole sequence. Change the demand from two ways to any number of ways, and each demand has its own smallest answer. Ask for a total reachable in just one way, and the smallest is simply 2. 1 cubed plus 1 cubed. Ask for two ways, and the smallest is the number we have been studying, 1729. Ask for three genuinely different ways, and the smallest jumps enormously, all the way to 87,539,319. That third number splits into three cube pairs, and here they are, all landing on the same total. 167 cubed plus 436 cubed, 228 cubed plus 423 cubed, 255 cubed plus 414 cubed. Three disjoint pairs, one shared value. Notice the jump. Going from one way to two ways cost us a leap from 2 up to 1,729. Going from two ways to three ways cost a leap into the tens of millions. Demanding one more coincidence makes the smallest number that delivers it explode. Give the pattern a name, and it becomes a sequence. The smallest number with n different cube builds is called the nth taxicab number, Ta of n, and we can ask how far anyone has actually pinned it down. The answer is not very far, because these numbers grow ferociously. The fourth taxicab number is already close to 7 trillion. The fifth is near 49 quadrillion. The sixth has 23 digits, more than 24 sextillion. Each new one required a serious search, and only the first 6 are known for certain. Beyond the sixth, mathematicians have candidates and upper bounds, but no proven smallest. To feel how hard this gets, look at the fourth one alone. Its 4 cube builds start from bases like 2,421 and 19,083, numbers you would never stumble onto by adding small cubes. Confirming that no smaller number has 4 builds means checking an enormous range with no shortcut, and the sixth taxicab number was only settled in 2008. Every step up the sequence is a harder search than the one before, which is why the list of certain values stops at 6. There is also a cousin worth 1 line. If you allow the cubes to be negative, so that you can subtract a cube as well as add one, the smallest numbers shrink dramatically. Under those looser rules, 91 already works 2 ways, 3 cubed plus 4 cubed, and 6 cubed minus 5 cubed. Those are the cabtaxi numbers, a different game with the same flavor. So the tidy little coincidence we started with is the second entry in a sequence that climbs out of sight, and the doorway to it is 1729. Step back to where we began. A number that looked completely plain turned out to be built from cubes in two separate ways, with nothing shared between them. We did not take that on faith. We fixed what a cube is, we swept the whole numbers in order, and we watched the count of cube builds sit stubbornly at 1 until, at 1729, it became 2 for the very first time. Then the same idea kept giving, a next number, and a next, and a whole sequence for 3 ways, 4 ways, and beyond. One split lopsided, one split balanced, meeting exactly at 1729, the smallest place where 2 cubes done 2 ways agree. That is the whole of it, and it is worth knowing the way Ramanujan knew it.